All right. I think we're ready to get started. So, welcome everybody. Thank you guys for coming. I know it's late. I know you guys had a long day. I know Mark and Parker are up on stage, so I'm very honored that you guys actually came to me. But I promise I'll make it worth your while. I want to talk to you about Salesforce IoT today. And specifically, I want to show you a use case that we've implemented a solution with a ferry company operating in Spain, in Europe. And they've actually built this solution. It's in production, and it does a lot of great things for them. And I'll walk you through the technical details, but also a bit of the business aspects of why this has become a successful solution for them. My name is Holger. I'm a product manager in the Salesforce IoT product. And I do work in Europe. I cover Europe and work a lot with our European customers, and this ferry operator being one of them. All right, quick legal disclaimer. So, what I tell you doesn't matter. Make sure you buy only based on publicly announced products and not on things that I may claim here. But what do we sell in Salesforce IoT? Salesforce IoT, we have launched a product, Dreamforce last year, just prior to Dreamforce. It's called IoT Explorer, and it is literally the gateway for Salesforce to consume data that is emitted from physical devices, physical things. And this can be a great number of things. These can be consumer devices, they can be thermostats in a consumer's home, they can be robots, industrial devices, and they can be things as big as ferries. And while we built this product, the Salesforce IoT Explorer, we had three principles in mind that we needed to meet for the implementation of this product. First, the product has to be very agile in use so that it supports rapid innovation. It's called Explorer for a reason. Most customers we work with don't really know yet what their IoT strategy should be, and especially the commercial aspects of their IoT strategy. So therefore, they want to try things, they want to be adaptive, they want to change it, and want to do this very rapidly. So we can't afford to give them a tool that takes months, to roll out. We need to give them something that they got production-ready solutions within a few weeks or even days to get to a first implementation, a first use case. So that's number one, rapid innovation. Number two is we are Salesforce, we are CRM, we own customer data. So we don't do IoT just for the sake of dealing with device data. We're doing IoT for the sake of bringing it together with the customer context data that we already own in Salesforce. So customer context here to us is key. Be able to merge your device data with your customer data and then serve your customer through these combined solutions. And that's leading into the third point. We're talking about real-time engagements. We are mostly about building the engagement platform that connects you as a business with your customers. And it can do this in many different ways. Can do this through marketing journeys, can do this through service case generation, can do this through community cloud, can do this through sales cloud and opening up sales opportunities. Whatever it is that you can do today with Salesforce, you should be able to do with the additional data that your devices, and in our case, your ferries, are going to emit and give you. So let's have a look at how this was actually done now for that ferry operator in Spain. Quick introduction on the company, Trust Mediterranea. I don't know how to pronounce them in Spanish. If anyone here does, let me know. It's a hard word to say. But anyway, these guys are a ferry company that operate 22 vessels for both passenger and cargo. They crisscross the Mediterranean Sea, so they go from the mainland to the Balearic Islands to north of Africa. And they have been doing this for 100 years, which tells you that their ferries haven't been, connected for that entire time. So IoT is something that we actually see can be retrofitted on even legacy devices. Here in this case, the ferry is fairly easy to track as it's moving across the sea. We'll have a look at that. And yeah, they transport as many as 2.5 million passengers per year. So what they were setting out to do is build an operations control center where they signed a partner in Spain called LeadClick. It's one of our Salesforce Platinum partners in Spain. And the goals for this operations control center were pretty impressive. They wanted to build a customer engagement platform where they can communicate more directly with their passengers through SMS or in-app notifications. In fact, Trust Mediterranea is using a Salesforce app as their point of sales for ticketing. So customers can purchase their tickets through a mobile app, and then they now can track the customer, but also engage with the customer through that app, push notifications. You know the spiel. They wanted to improve their sales operations, and in fact, they can do this not only for their current customers, they can even with the solution monitor their competitors' ferries and understand if there's perhaps upsell opportunities if the competitor's ferry is late to arrive at a given port and they're about to depart. Why not send that customer waiting at the port a discount, an incentive to switch tickets? They had cost savings and operations management in mind. So what they're doing with this solution is track the ferries while they're crossing the sea and make sure they're operating fuel efficiently and don't burn too much fuel. If the captain does drive too fast, they actually engage with the captain directly using Salesforce. And last not least, safety security is important. They keep track of the manifest of all the passengers sitting in a ferry in Salesforce, and then also the emergency contacts. If the ferry, for whatever reason, stalls out at sea, you cannot just pick up the phone and call your family simply because you won't have signal out there. So what Trust Mediterranea can do now for you is contact your family with an SMS push notification, let them know you're going to be late to arrive because your ferry is stalled out at sea and they're attending to it. Yeah. So these kinds of things are all going to be possible now. Here's how we've built the solution. So if you know anything about vessels, marine vessels, they are equipped with beacon devices that are mandated to send signal to a public marine traffic information system. And that is so that the ferry or any other vessel can be tracked at any given time. So they are mandated to send the timestamp, latitude, longitude, where they are, the course over ground, speed that they're driving at, the heading, the destination, the elapsed time of arrival. So all these data points are now collected and available in these marine traffic systems. They're called AIS, Automated Information System. And what we're doing with Salesforce IoT, we have an Apex, basically a client that will just consume from the AIS, Automated Information System, and emit something called platform events into our core platform using platform event bus. And then they're going to take these platform events and join them with the context that we have in Salesforce, and that includes the details of the journey, who's the captain, what type of vessel is it, what are the customers who have tickets and are actually on the manifest for that given journey. So that's what we call a context. The context is now a join of the incoming events, the signals, with the CRM data that's all in Salesforce. And then using that context, we're defining the business logic and something we call orchestrations. Orchestrations are rules, declarative rules, and a state graph where these rules get executed and then trigger action. And these actions, we'll see in the demo, these actions can go towards Service Cloud, they can go towards the mobile phone, we'll see SMSs, but they can also go towards Lightning apps. And this Operations Control Center is in fact the Lightning app, a number of panels that show you exactly the state of every ferry and the operational state in an app that has been developed as a Lightning app. And the last bit here on the bottom of the screen is, because this is all working live and we're actually using live data in order to intercept and simulate like a case, an error case or a delay situation, we had to build a little simulator so that we can just inject an event that pretends there is a boat, that is a ferry that actually has a problem, right? So without further ado, let's do the demo and show you what that looks like now in the solution. So here, the first screen shows you exactly this Lightning app, and that here is a status panel that was developed for the customer, where they see for their entire fleet, 22 ferries, every individual ferry, what's its current journey? Where is it departing from? What port? Where is it headed to? What's the expected time of arrival? Is there a delay? Is there a schedule issue? Down here we see a feed of events that show us for every single ferry, and they're identified by some primary key called the MMSI. We're going to see what's happening with the ferries and whether or not there are any alarms being triggered on the ferry. Here, this view shows us now Salesforce IoT. This is an orchestration where we monitor the state of all these ferries in a state graph. And right now, we're seeing there are 16 instances, 16 ferries where we're getting signal, and we're just monitoring it. No single ferry here has a problem. None of the ferries have a problem. None of them are stopped or stalled at sea. So they're all behaving quite normally. And now I'm going to show you what would happen if any one of these ferries was not behaving normally. So for that, let's keep playing this. All right, so behind any of these states are rules, and now I'm trying to fire one of these rules, one of these actions. So I'm using here the simulator that I've mentioned earlier, Heroku app, and I'm simulating a navigation status. This is also a spec. This is a standard code that is used in the marine traffic world. So I'm sending this code pretending that the ferry has a problem. And so immediately switching back into our orchestration view, into the traffic view, I now see there is a single instance of a ferry that has some technical problem. I'm switching over into the Salesforce Service Cloud, and I see that we have created a service case automatically for that ferry. And the owner of the case, or the originator here, has been IoT. Yeah, it's the Salesforce IoT Cloud. We know what the problem is because we get that from the event payload. The navigation status has been reported. We know who the captain is because all that is context that we have in Salesforce. And basically now we know how to engage or contact the captain and also make service personnel available at the port if that problem can be fixed at port. Okay. So now this is a second view over the same data. Here's a map view where we're plotting the journey of every ferry as it's happening in real time, and along with these operational data and statistics. Now, it's all nice and well if you are the operator who has this view and can tell at any given time what his fleet of ferries is doing. But for us, it's much more interesting to actually help a customer who is maybe sitting there at a port in Barcelona waiting on a ferry to arrive so that he can start his journey. And so what happens if a ferry is late to arrive, right? So typically you're sitting there at the port, you're monitoring or you're waiting on speaker announcements, but wouldn't it be nice if you could leave the port and you could do something out and about, and the system, based on Salesforce IoT, would notify you of the expected arrival of the ferry. And that's exactly what we're simulating here now. Again, this is working live. I'm just simulating it because none of the ferries at the time was, in fact, delayed. But here I'm simulating that a ferry is 2 hours late, and I'm sending it to the phone of that passenger who we have on record Trust Mediterranea customer support. We know when the ferry is expected to arrive, so he can do something better than sitting at the port and waiting. Yeah. Again, this is now controlled by another orchestration, and the key here is the same event stream can serve a number of different business purposes. Yeah, we've already seen one, the mechanical problems. Here we see now the other one is late arrival notification, all driven by one and the same event stream, a pretty simple event stream, in fact. And now this one is the third and last view. This one gives us KPI charts over the telemetry data, the signals that we're getting off the engine from every ferry, right? So we can detect at any given time how the engine's operating, how hard it's running, and how much fuel it's consuming. And then we can even do something like send the captain chatter feed on the boat, and in fact, their captains are equipped with Salesforce mobile apps, so we can send them chatter feeds telling them, look, you're driving too fast, you're 35 knots, optimal speed would have been 25 knots only. So slow down, for fuel efficiency, we need you to drive slower. So this is not, a fictitious story. This is literally how they interact with their captains out there at sea. Last view, quick architecture diagram. So the way this has been implemented, as I said, on the left-hand side, the vessel data coming off the AIS system. It's public domain. You can purchase subscriptions. Everybody could build some solution like this today. The way this has been built by the partner, LeadClick, is through scheduled Apex code, which consumes the data from AIS every few seconds and then forwards it into IoT Explorer as platform events. The platform events then get merged with the IoT context, the Salesforce context data. In this case, we have data on like the journey, the passengers, the captain, and the vessel type itself. And then that context essentially drives the orchestration, those state machines, in which we monitor the state of every individual ferry. Here it's a fleet of 22. Imagine this would be thousands of devices, would work exactly the same. And then based on declarative rules, we're then going to either fire alarms into, through case objects, or we're going to fire just events into regular status objects. And then we can visualize these in the Lightning application as alarms, in the map, as KPI charts. And we can also allow external subscribers, like a notification system that's sending out the SMS. We can allow them to subscribe to these events through commit declines. And this is literally how this has been built, and this is how this works today. If you have not been exposed to Salesforce IoT, I'd encourage you to check out. We have a full exhibit there on the floor. It's called the IoT Village. It features Lego city objects in which we demonstrate a number of showcases, built them in small Legos. We have trailheads out there. One of the trailheads is a very nice hands-on trail featuring an electric imp, which is like a $20 device off Amazon. You can use that to start emitting signal and then processing signal in Salesforce IoT and see how that all works. And last not least, we have API guides. We have user documentation, obviously, but we also have developer documentation. So you don't have to do any of this with a graphical UI. This can be totally automated and programmatically built with API. All right, and with that, I'd like to thank you. If there are any questions, we got a couple minutes left. Feel free to ask now or see me later if you want to. Thank you very much. Thank you.